and I'm the event coordinator for the Math Club.
My name is Steve. I'm a senior math major. I'm the president of the math club. I don't know if you guys know.
Yeah, so I'm Mark McLean, and I'm the graduate director at the mathematics department.
And I'm Scott Sutherland. I'm the chair of the math department and still undergrad director, although somebody wants the job.
I'm sorry. Yeah, I think the most general question I could ask is, let's say, could you describe the math major? Like, if I was a student that was either coming here as a first year or transferring or wanted to switch majors, what could you say to me as to like still be the math major?
I mean, I can describe the math major, in terms of classes, but that's not really what you're asking, right?
Yeah.
So I think really, if I can rephrase your question, it's maybe why should I major in math, or what good would it be to major in math? And math, well, I mean, everybody's here because at least they like math a little bit, and it provides it's a very broad field that gives you a lot of options to look very closely at certain things, and even if you don't end up becoming a professional mathematician, it gives you a good background for a lot of different things. So there are people who major in math and then go on to be lawyers. There are people who major in math and go on to be in business, or a lot of people do computer science or other things. It's a good, I mean, I don't know, I guess I don't have to sell any of you on math because you're here. Is that kind of what you're looking for? Okay.
As a follow-up to that, maybe what sort of paths have you seen? I guess you sort of answered it. What sort of paths have you seen students taking on after graduation?
So,
I guess it would be relevant to maybe include like doctoral students who went to industry.
do you want to start with doctoral students?
I mean, just to get, some students, like mathematics so much that they want to continue studying it. Yes, you can apply for the PhD afterwards, and many, a number of undergraduates every year apply to PhD programs and master's programs, and if you like it, you can just keep going. I don't know what else to say. I'm not really sure what to say.
Okay, so and then there's obviously you can go to graduate school and do more math, and maybe go into academia and continue doing math forever. But there's a lot of things that you can branch out. I mentioned some of those earlier. And it's not always necessary that immediately upon getting your undergrad degree to go directly to graduate school. Some of us didn't know they wanted to go on and do math. I tried teaching high school for a year at a private school, discovered that was not what I liked, and then I went into computer field for a couple of years, and that was really exciting for a year, and then it got boring, and I said, oh, I want to go back and do more math, and then I went to graduate school.
I suppose there's many different kinds of graduate school that's sort of mathematically based, that's sort of more applied. Even if you're doing pure mathematics, it's a major, you might sort of end up doing more applied things later on. We've had people go into sort of, or even like computer science and things, but it's sort of very mathematical still. And all of those areas are very interesting, I think. So
how would you if most of us are still in undergrad, how would you prepare for, if you wanted to go to graduate, how would you prepare for that?
so there's several things. Yeah, so getting into a PhD program is quite difficult. It's quite competitive. You need, first of all, you need good grades, especially in more advanced courses. You need, especially for US PhDs, you need good project work. And so you should really, you need to, there's like this summer REU, for instance. We had a PhD student who did one of these summer REUs, and sort of partly based on that, we sort of got into the PhD program.
What did you expand on the REU? Like, what is that?
So, I don't know, daily. You all maybe just received an email from me about the Math 402 and the REU. But let me say some things about what it is. It's structured as a semester, if we count summer as a semester. It's structured as there's like a warm-up course in the beginning, which will be Math 402 this year. I'll say some more about that in a bit. And then that lays the foundation for some research in a topic chosen by the supervisor. This year it's on fluid mechanics and fluid dynamics. And then in the summer, the REU, we fund a certain number. The average number is 3, but sometimes it's 4, sometimes it's 2. We pay for the students' housing on campus and their meals so that they can spend the summer here doing research on that topic. And then in the fall, they either continue their research and write an honors thesis in the spring, or they write an honors thesis in the fall, depending on how far they get into the research project. As I mentioned, Daly did it this summer. Not everybody who takes Math 402 will be funded for the REU, but again, this summer there were a couple of people, was it 2 or 3? I don't know. There were two
Two others that were funded.
Right. No, 3 of you got funded. Yeah, 3 people got funded, but I think 5 or 6, 5 people actually participated because some of the other people just said, but I want to do this. Okay, well, we can't pay for your housing. It's okay, I still want to do this, and they did that. So we sort of had 5 people do the REU, but our funding only covered 3 because we have an endowment. Somebody gave a bunch of money, did an endowment to pay for this every year, and the money from the investment is enough to cover housing and food for 3 people for the summer. So the selection of who gets funded is done by a committee, but mostly the person who is running the project. But just because there's that one project, if you're like really interested in geometry and you want to do some research in geometry and we're doing fluid dynamics, that doesn't mean geometry is no hope for you. You just talk to various professors and see if you can find someone who will work on a geometry project with you during the year, over the summer, whatever.
Also, follow-up question on that. Is there any sort of departmental support for students who do want to do projects like that this summer?
What kind of support?
Departmental support.
Depends on what support means. So sometimes there will be money available. I can't guarantee that there always is. Some people have funding for students on their grants. The department does have some money, but it's not an infinite amount. So it is possible to get some amount of support. Usually it's not at the level of, housing, as probably many of you know, is at Stony Brook is not cheap. And so it's not usually at the level of paying for your housing and all your food. But, it's often possible to come up with $1,000 or $500 or something to support you to do that.
just specifically some math REO that you know of as trying to go specifically?
Other opportunities for research?
In general, at least of interest to mathematics students because
So, I mean, in general, yes. I mean, we have several students doing research projects with faculty, basically because either the student had an idea that they were interested and they said, oh, you know about this stuff, I'm interested in this stuff, and they talked to a faculty member and they said, okay, let's do a thing. Or sometimes they maybe had been taking a course with a faculty member who mentioned he or she did this kind of math, and projects arose out of that. So this can be very informal, it often is some kind of independent study, and so on.
And is independent studies 4 credit, usually? Or?
Not the number 4, FOR, right?
Yeah.
It can be between 0 and 6 credits. Usual number is 3.
So we'll get back to the topic of graduate school because that's what we do. But taking graduate courses is often important for applying to graduate schools in the future. So I'd like to ask what the current process is in taking graduate courses and who should be the ones enrolling them.
So that's my question. So,
It's the most important question.
okay, so yeah. So first of all, before you consider taking graduate courses, you should have a really strong background in all the advanced, most of the appropriate advanced undergraduate courses. You should be really strong at, you should have done well at, like say, real analysis and Math 324 and these kinds of courses. I think. And then after that, you might say, well, you might be interested in taking one of the graduate core courses. So they have course numbers 530 to 536. And if you want to do one of those courses, my policy at the moment is you talk to the instructor who is going to teach the course. They should sort of make sure that you are ready to do such a course. And then if they think you are, then both of you should, you and the course instructor should message me, and I'll give approval. You should really make sure you are capable of doing the course, because it's not good if you do take one of these courses and you sort of crash out, and unless people have personal problems. We've had this before. We've had someone whose grades weren't so good because they had personal problems. That's okay. But if you're crashing out because you didn't have your background wasn't solid enough initially, just because these courses they're at a higher pace. So for instance, if you've done 324, I think that's sort of one of the more advanced courses. But then if you compare it with the sort of analysis course, I've forgotten the number, but
Analysis 1.
analysis 1, I don't know what the number is.
It's 5.
But that one is sort of, I would say it's at least 50% faster, or maybe twice as fast. I don't know. So you really have to.
Sometimes they try to make it faster.
Oh, really? Okay. It may depend a little bit on the professor, but on average, it should be about 50% faster, I think. And so it's really good, but you just have to be aware of that.
the intermediate grad courses or the topics classes?
Yes. So, yes. So some people do take the intermediate classes. I kind of, personally, I prefer it if you sort of, the intermediate classes require knowledge of the core courses. Some of the intermediate classes require, knowledge of like, say 4 out of the 6 core courses. So, you need to sort of have that background. I don't know about taking such courses for credit. The problem with these courses is there's sort of minimal homework and there's no exams. So it's
difficult to do for undergrad. It's difficult to allow undergrads.
Yes, but we do allow some undergrads to do it. Yes.
So let me, just because we discussed the credit issue, the university does have a limit on the number of graduate credits that can count as an undergrad, that will apply for TAP, will apply to the 120 credits you need to complete the major, and so on. That limit is currently 12, it used to be 6, so that would be 4 courses. Beyond that, sometimes you can petition and ask them to raise the limit, but there is a limit, and it's important to realize that. There are ways around this. You can take the course as an independent study, but don't expect that you're going to take 30 credits of graduate rather than taking your senior year of math classes, unless you already have a whole pile of credits, because you need 120 to graduate. You can we do have people that do that, at least one of them is in this room, but we have to really work around the administrative restrictions that the university imposes. So, I just want to point that out. And also we have had, as Mark mentioned, you really need a solid foundation on these. One thing that students tend to get a little confused about is, why should I take the undergraduate real analysis when I can just take the graduate analysis? And even if you can survive the graduate analysis, you will not get the full experience out of it unless you've laid the groundwork, right? What happens in the math major, in mathematics in general, is we keep going back and revisiting what seems like the same topic to do it in more generality and more depth. And sure, the analysis, the undergraduate analysis course is looking at continuity and derivatives and how functions behave. So is and then 324 is the measure theory course, and the core analysis course is kind of the same material, but it's a lot deeper, and you won't, if you haven't done the other stuff, you won't get as much out of it as you should. And we've had a number of we've had a number of undergraduates that come in really strong as freshmen, have all of this experience, and they manage to skip over a lot of the undergrad courses, and they get mediocre grades, and they don't really understand the material, and it's a disservice to do that, disservice to yourself to skip everything. Because going faster doesn't mean doing better. But on the other hand, if you're really prepared, then it's the right thing. And also about the topics classes, you can just go. You don't have to take them for credit. If you're ready to do them, you can go and listen.
It is a little bit better to have a paper trail, especially if students.
Well, especially when you're applying for graduate schools and so on. So let me give a little background, most of which you know. Stony Brook had this limit of 6 graduate credits for a long, long time. And the math department in particular, we always tried to work around it and petition for more and everything. And at one point, I asked one of the administrators, what is the purpose of this limit? And nobody knew. They just said, well, it's a rule we have. Well, why do we have this rule? Because we have this rule. Well, but what good does it do? It's been in place for at least 30 years. Nobody knows. It's always been in place since anybody here knows. Okay. Do other SUNYs have this? I don't know. Well, why don't you check? Okay. And they checked, and Stony Brook was the only SUNY that had a limit of 6. Some others had a limit of 12. Some others had no limit. And so took it to the undergraduate curriculum committee and the undergraduate council, and they said, yeah, this is silly, we'll raise it to 12. Maybe we'll make it go away in the future, but let's start with 12. So the limit is 12. It's not clear whether that's, just what the limit is now, and in a year it'll be infinite, or, but right now the limit is 12. And since it was only raised last year, we haven't yet had to petition, although I was just talking to someone now who already has 12 credits of undergraduate, who wants to take more graduate courses. We'll petition, maybe they'll say no. But that's the status.
I'll just ask one more question about graduate courses in general. Are there any changes to the curriculum maybe in the future? Just wondering.
Just the,
Yeah, or is it just going to be?
at the moment it stays the same. Changes to courses takes a long time. We haven't. I think that takes years for us to actually change courses.
We do sometimes introduce new ones, like the probability courses.
But I think again that has to go through all the way through Albany and back, and that's takes 2 years or something. It's ridiculous.
Yeah.
But so the answer is no. I was thinking I might change some of the numbers and make them more logical, but I don't think it's a good idea. We'll see.
Yes, I'm going to ask more about undergraduate courses now. So a topic that comes up very often by people is about the sort of different tracks that some courses have. Like there's 200, MAT 200, MAT 250, there's MAT 319, 320,
310, 315.
Maybe, what are the purpose of these courses and the differences, and when, why should people take action?
So 319, 320 is the oldest one of these that has bifurcated into a less advanced, more advanced version. And then also 200, 250, and 310, 315. And the reason for them, is that since we have a wide range of students that are taking mathematics for a variety of reasons, some of the students are like, yeah, get on with it, and other ones are like, can't, it's so hard. So this is why we have the 2 versions. And at least for those 3 courses or 6 courses that start as 3, they start as 1 to give students who wouldn't necessarily have enough information to make the decision, yes, this is suitable for me, time to get their hands dirty and determine that, yes, this is more appropriate for me. No, I'd rather stay in the lower level course. They tend to start off with the slower course, and then the faster course branches off. I don't think we don't really have two courses that, you know, start an advanced version and a less advanced version, except sort of in the calculus, single variable calculus sequence, we have, you know, math 125, 126, 127, and we have math 131, 132. Even there, we have some sort of mixing in that, I mean, I don't know how many of you took those courses, but we have this up until week 6, you can say, no, I'm in over my head, I can drop down. So it's kind of the same, except we let the students choose, and then if they choose wrong, we can let them, they can move down. I guess the other track is we do have 307, 308, as opposed to 203, 211, 303. But did that answer the question? Sort of, maybe, kind of?
And also, do you think it's beneficial for students to be taking maybe the more advanced classes, or do you think it's an individual case-by-case basis?
Okay.
I only ask that personally because I see a lot of students who probably should be taking that more advanced course, but
don't.
that they end up like get psyched out and they just go for the easier version.
So, I mean, in terms of so there is one difference with 319, 320 versus, say, the 310 and the advanced version 315 or 200, 250, in that 320 is a prerequisite for 322, the multivariable analysis, and 324, the measure theory class, because there's material that's covered in 320 that is necessary for those other courses that is not covered in 319. The material that is covered in 315 that is not covered in 310 is nice to know, but it is not the prerequisite of any specific undergraduate class. Probably if you're thinking of taking, you know, the graduate algebra course and, you know, having the background from 315 would be helpful. Similarly, 250, there's more material in 250 at a slightly higher level. It gives you a better background, but on the other hand, maybe you don't want to work that hard. Or maybe you're just better off going at a slightly lower pace. You can figure out that, you can find that other material later on your own. Different people learn in different ways and at different speeds, which is why we try and offer things at different levels.
Speaking of the, now you mentioned 322, 324. Yeah, 324. So the undergraduate curriculum requires one more analysis course, and 322 and 324 are options along with 341.
Yeah.
What are the differences between those three?
So they cover very different subjects. 341 is a course on separable partial differential equations, the heat equation, the wave equation, and the Fourier series. Maybe you know what these words mean, maybe you don't. I could tell you wrong. 322 is a course on analysis. It's an analysis course, but on multivariable functions. In some sense, 319, 320 is redoing single variable calculus, and 322 is sort of looking at the ideas that come up in multivariable calculus, but from a more advanced viewpoint. Probably, and then 324 is a measure theory course, which is a course at generalizing the way that integration works. Probably of those three, I think somebody planning to do graduate mathematics or physics really should be taking 322. That isn't a course to skip. 324, that material is revisited in analysis 1. If you didn't learn what Lebesgue measure was as an undergrad, it is there in the first analysis course. But often a lot of the things that are in 322 are just assumed. 341 is nice, but okay. And 341 has a lot less theory, a lot less proofs. It's more like a second semester of the differential equations course as opposed to 322, which is much more abstract and talks about forms and things like that.
I will say with regards to 322 versus 324, I often see a lot of graduate schools, if you're thinking of going to graduate school, they often, if they list requirements that they want to see in your transcripts, the classes you've taken, they often list stuff both in 322 and 324. So I'm just putting that out there.
Yeah, no, I think both are, if you're really planning to do a graduate program in mathematics, you really should take both. But if you have to choose one, I think you should do 322. But that's only, if you're a senior and you only have space for one class left. Also, 322 is only in the spring, 324 is only in the fall, so sometimes the timing can mess you up.
So, also, what are independent studies, and how does one end up actually taking them? People are often confused about the topic of the process and the way they use purpose.
So the purpose of an independent study is if there's something that you want to learn about that doesn't correspond to a class that we offer, you can often find a faculty member to work with you on an independent study. Also, sometimes this is one of the ways that we work around the 12 credit limit, that the independent study consists of going to a complex analysis course, doing all the homework, taking the exams. That's just administrative fakery. But actual independent study, you say, hey, I want to learn about algebraic geometry. There's no undergraduate algebraic geometry class. I'm not ready to take the intermediate course in algebraic geometry. Professor Lazarsfeld said he would work with me, okay. And usually, it typically means your supervising faculty member will say, okay, I want you to work through this textbook. I will see you every Wednesday at 3 o'clock, and we'll see how you're doing. But the exact arrangement can vary. It can also be a research project. You're working on something, it isn't really studying a text, but rather working through some project. It's really just a one-on-one relationship, or sometimes it's one-on-two. I've done an independent study with 2 or 3 people. And the number of credits is variable. You can sign up for 0 credits, which means you're doing very little work, but you get a little something on your transcript that says you did this thing. One of the things in the REU is you sign up for a 0 credit independent study over the summer. You can have more than 1 credit, but then you have to pay for it. But you have to sign up for something so that you can live on campus, which is why the REU people sign up for a 0 credit independent study. A 1 credit, there's a student doing a 1 credit independent study with me now. It basically means I check in with him a little bit. And it's 1 credit. It's not a big deal. 6 credits, Utah has done a 6 credit independent study. It's, you're spending half of your time doing whatever that is. Did that answer it?
Yes.
Okay.
I guess also, what is the advanced track and what's the departmental honors program? Sometimes people get these confused, so maybe where the difference
Understand.
between them and also where each of their positions.
So let me talk about the honors program first, because that's more straightforward. Both of them are somewhat amorphous. The honors program, you get departmental honors. So you don't have to be in the honors college to graduate from Stony Brook with honors. You can get honors within your department. To get departmental honors, you have to write an honors thesis, which is like an independent study, but you have to produce something. You have to write some kind of research. It doesn't need to be, it's nice when it's some new mathematical idea that you've researched, but it can be primarily expository. It can't just be, I'm going to read this book and write about it. You have to synthesize several sources, and it can be an exposition. So you sign up for, I've forgotten the number, $4.95. It's a 3-credit class. You find a supervisor that's going to read your supervise your thesis, make sure you produce something reasonable, and at the end you produce it and it's okay, and you get the honors thesis. But also, you should take at least one of Math 322 or 324. You should have good math GPA, and you need to take either Math 401 or 402 at some point. So don't just do the minimum of the major, take a few more courses, do well in all of your math courses. I forget, I think it's a 3.6 math GPA, something like that. Write a thesis, then honors. It may say in the bulletin you have to sign up, but basically when we're clearing people for honors, we say, who's written a thesis? Okay, now let's check if they have the other requirements, then they get honors. The advanced track is not disjoint from honors, but it's not the same thing, in that the advanced track is just sort of a suggested collection of more advanced courses that should prepare you to get through the undergraduate syllabus faster, to be able to take graduate courses and do more advanced math. Obviously, you can take a long time to complete the undergraduate. There's a lot of courses that you could take. And the advanced track is sort of formulated as a way to give you a solid grounding in undergraduate mathematics at the fastest rate. But it's not really a formal program. It was originally conceived of as a formal program that you had to sign up for as a freshman, and it just didn't work, because a lot of people didn't really realize that they were good at math and wanted to do math that early. So like Math 250 was supposed to be the first class in the advanced track, but it didn't work that way.
I have to ask, what's the future of the advanced track, if any? Currently, most people notice that on the bulletin, the list of courses for it, or reference list, are all, outdated. Is anyone planning to do anything with them?
So Professor Vero is sort of the person who really was pushing the advanced track, and he is planning to do some work on that and clean it up and make it make more sense. But all of these things take a lot of time. As Mark mentioned, it takes a while because new courses have to go through SUNY and stuff. And which makes it hard to design new things, because all of this administrative baggage means you need to know what you want to do and get it approved, and then you can try it, and then maybe it worked. So there's this, and you know, for undergraduates, they're only here for 4 years typically, some of them 3, some of them 5, but, so you don't really see the changes.
Yeah,
That covers most of our questions. So
Yeah.
I think maybe we'll open it up to the audience for questions.
Hello, can you explain the difference and recommendations for somebody who wanted to go to grad school between topology and geometry, differential geometry of surfaces, and I think Euclidean geometry, or I don't know what the other one is.
Yeah, do all of those.
Yeah, do all of, oh, okay.
Was that a question here, wasn't it?
I think it was.
Was it?
Well, there was a question about what's the difference between geometry and algebra and analysis and topology. They're math.
Right. Right. but I
Well,
meant-
that's not a helpful
But I
answer.
meant out of the geometry, is there one that you recommend, or it's okay?
All of, so, you know, all of them are good, but they're all different, right? So, yeah.
All of those topics are sufficiently broad that you're not going to have a problem finding a graduate school with those interests.
Okay.
Yeah, and, you know, yeah. So, I mean, you know, we can define what those terms mean, but I don't know that that's what you're asking.
I mean, if you start getting obsessed with something very specific, that can be a problem.
Right.
But if it's sort of geometry, you know, or differential geometry even, or something like this, or some area of algebra, just generally,
Right.
that's sort of fine.
Yeah, my question was similar to the 322, 324, 341, similar to that question.
You're talking about the specific courses, right?
Do you mean just in terms of courses? Or do you mean in terms
Yes,
of
I was
topics of
talking in
math?
terms of courses.
Okay, so,
Courses.
sure, so there's, let's sort of start with the undergrad courses.
Right.
So there's Math 360, which is geometric structures, which really looks at planar geometry, or surface geometry, which comes down to there's sort of 3 uniform types, which is flat geometry, Euclidean geometry, the kind of thing you maybe learned in 10th grade or 9th grade, but maybe didn't learn it very well or whatever. But if you change the curvature of the surface, then things change. So that if the surface that you're working on is a sphere, you get a different geometry. If the surface that you're working on is hyperbolic, you get a different geometry. So 360 sort of goes through that, those variations. It's not a highly abstract course. The differential geometry course, on the other hand, is sort of looking at all of that stuff in much more detail, requires some analysis, some linear algebra. It's a much more advanced class. The topology course, Math 364, the other one was 362, the differential geometry, also is sort of, you know, I don't think analysis is a prerequisite, but it kind of should be. And it's looking at, generally, it's point set topology, often in surfaces. There may be some geometry built in there. Sometimes it's in higher dimensions, but a lot of times it's just in 2 and 3 dimensions. As opposed to Math 530, which is just general topology. That's the graduate course. It's a lot more comprehensive. And 540 even more so. Did that answer what you were asking?
Yes. thank
Okay,
you.
great. Yeah.
Yeah, so I want to ask, like, let's say if I want to get exposed to, like, fractal geometry kind of thing, then what course should I take? And let's
So-
say, yeah, never mind, yeah.
No, that's fine.
Yeah, and the same question, but replace fractal geometry with optimization.
So the dynamics course 351 often does some amount of fractal geometry because often fractals arise in the context of iterating functions, which is what the dynamics course looks at. It may do some continuous time dynamics or differential equations, looking at flows and so on. Kind of depends on the taste of the person teaching it. So that's offered in the spring only, but that's not irrelevant. We don't actually have a course on fractals per se. Certainly some of it can come up in the measure theory course, but somewhat indirectly. I don't know, they don't usually, do they even usually do things with Hausdorff dimension in that class? Maybe, maybe not, depends on who's doing it.
Maybe 533. I don't know about it.
Yeah.
Depends on who's teaching it.
But also, you know, if you have a specific interest in, I don't know, I want to study iterated function systems and what fractals I can generate from iterated function systems, that might be a good topic for an independent study. If that's what you want to do. And we have people around that know about that stuff, right? We have a lot of people who do dynamics. And, you know, it's certainly a reasonable choice for it. It also would be a reasonable choice if someone felt like it for a Math 401. Just haven't done that in a while. I don't know if we've ever done that. I don't think we've had a fractal geometry 401. I mean, sometimes I do something like that when I teach 331, but sometimes not.
For the 402, when did they decide who gets funding for the REU? Like when is the
Probably
place?
Marchish.
Marchish.
So need enough of the course to
Right.
have happened that they can get a sense that, yeah, this person's going to be great. So probably sometime in March.
Thank you.
If it makes a difference because you say, I'm going to do an REU no matter what, and I have a deadline for this REU that's in Indiana, I need to know, then you should let the organizer know that it would sure be helpful to your life if you could know by the deadline for that one, whatever. I don't know, just
Yeah.
go ahead and ask.
So I was interested in taking Math 308 for next semester. I haven't taken Math. I'm not taking Math 307 this semester, but I
Did
just
you take
have
211?
I have the prerequisites for it. So I was interested in taking it, but I was just wondering what to expect from it because I was actually just looking at the description and it said it was like a little bit more theoretical than Math 303. So I was wondering kind of what that meant and what to expect if it would be more computation or more like theoretical.
It's still going to have some, it's not going to be analysis. So the point of 307, 308 as a pair, let's first think of them as a pair, is that multivariable calculus, differential equations, and linear algebra are friends. You need some linear algebra to make sense of multivariable calculus, but the standard multivariable calculus syllabus kind of sweeps as much linear algebra under the rug as possible. Whereas if you study some linear algebra, then you can say, you know, the derivative of a function from R3 to R1 is really the same thing as the derivative of a function from R1 to R3, which is really the same thing as the derivative of a function from Rn to Rm. They're just all linear maps, and there you go. And if you have the language of linear algebra, you can make sense of that more efficiently. Similarly, in differential equations, the solution to a linear differential, the solution space of a linear differential equation is a vector space. So having the language of linear algebra helps make more sense of what's going on in differential equations. And it is like a more advanced version of what 303 does, because you have more tools, you can say more and get a little further and a little deeper. It's typically, 303 tends to be a little more calculational. That doesn't mean that in 308 you're going to have to prove everything all the time, although sometimes the instructors get a little carried away. And 308 is essentially analysis. So.
What's from maybe awards or scholarships or fellowships have you seen the students in the department getting, and maybe are there any students who maybe think of actually going for? Like, I think maybe in particular in my mind is maybe the Goldwater Scholarship. I don't know if any students here have ever done that, but I think it's something that
We have had a Goldwater Scholar, and there's another one that's similar, and I've forgotten its name.
Some scholar water scholar?
So there are various scholarships / fellowships that are national or international and quite prestigious and quite rewarding. What's the one where you go to Cambridge? What's the one that Kevin did?
Churchill?
Yeah, Churchill, right.
I was saying there's Churchill in particular.
Yeah.
I've looked at the winners for that. They all seem to be like Putnam Fellows, or like they won like major awards already. So.
Yeah, well, I mean, so all of these things you're all eligible for, but they're very selective. So we had a Churchill Scholar. Was Kevin an undergrad? I don't know. Like 10 years ago, 9 years ago, this guy was a very strong math major, did a lot of other stuff, and that sends you to Cambridge for 2 years, 3 years, a year, 1 year, and then then he went to get his PhD at MIT, and then he came back here as a postdoc in the Simon Center, and I don't know where he is now.
Amherst now.
Where?
Postdoc at Amherst.
At Amherst. Similarly, we had many years ago there was a Goldwater Scholar. It's a similar thing, but not the same thing. These things, the university, they're not just for math. They're in many fields. And I'm sure you've heard of like Rhodes Scholars and all of the, actually maybe they got rid of Rhodes's name. Anyway, there's all of these various prestigious scholarships that certainly it's not unreasonable if you are a good candidate to apply for, but I wouldn't assume you're going to get it. Because, they give out 5 or 3 or 1 to everybody in the whole country that applies, or sometimes internationally, so they're, a big deal. But we have some very good students here, so worth going after. There are some awards that the department gives every year, where we try to recognize our good students. You can't apply for those other than be a really strong student. The faculty says, oh, well, this is our best senior, or these are our 3 best seniors, depending if we can't decide or not. These are our best juniors, and so on. It is by no means as prestigious or lucrative financially as the other one, but it's a nice thing to win.
to 402, what if you like, let's say enroll into 402 this semester, but then you realize that like you don't really like it or something, then if you do 402 again the following semester, how does that work in terms of summer RU?
So suppose you enroll, well, so like Daly's ineligible to enroll in 402. I mean, she can enroll in 402, but she can't do the RU for two reasons. Number one, she's graduating, and number two, she's already been in the RU. So you can only do the RU once. You can take 401 and 402 as many times as you like. They're repeatable for credit. You can take them 6 times if you want. If you enroll in 402 and you're like, well, yeah, that was nice, but I don't want to spend the summer doing that, you can wait until next year and try again. That's fine. We have had people who, so this is the first year that 402 is the summer math prep class. But we decided it makes sense to fold those together. But we've had people in the past that did the summer math prep class, weren't chosen for the summer math or didn't want to do it, and then did it again the next year. That's fine. So, you know, you can only be a summer math recipient once, but you can do the material a lot. Well, a lot is like 2 or 3 times, at most 3 times, because you're only here for a finite period of time. And you can take 401 and 402 every semester if you want. The topic does not repeat any more often than 5 years. So there's at least 10 topics, but I can only think of, like, in the last 20 years, I can really only think of 3 or 4 that have been repeated.
I just have a simple question. The summer is distinct from actual summer. You still have to like apply to it and be accepted to it, but there's also other students who can attend the summer without being.
Yes, absolutely. So if you're not able to do the summer math thing, but you want to do a course on fluid mechanics, by all means take 402. It's fine. The only thing that we've changed is instead of having an independence, having a study thing for summer math and having 402 at the same time, now they're one class. And this was mostly to make it reasonable for the faculty who are running it. Because we all have to teach a certain number of classes and independent studies don't count.
Yes, I was going to say, also he wanted to do an independent study another semester with Dr. Vargas. I considered doing that with him this semester, although I didn't end up going through with it, and so he was quite friendly. And I think that he'd be up to it more likely than not.
Mm-hmm. Yeah, so, you know, he's a very good guy. Should be a good class. And he's very energetic and interested in students and good stuff.
Well, mine's more like a specific like my research kind of thing. So I'm going for the ag program and I need 6 required mathematics courses. I'm not like,
Okay.
yeah. So like I'm not a big proofs person. So is there any courses that you recommend that are specifically like the main focus is?
So you have a bunch of required courses and then you have 6 credits of other math stuff. It depends on what you like. I mean, you know.
Because I was reading descriptions under each course and they all were like really like, I don't know, I could tell what they really talked about.
Well, okay, so, I mean, I think, right, so, you know, you read the description of the dynamics course and you go, what does these things mean? So what might make sense, you know, is to I don't know, come talk to me or come talk to somebody else so that we can spend 20 minutes saying, this is what this one does. Ew, this is what this one does. Oh, that was neat. You know, like the number theory course does have some proofs in it, but it builds on some of the stuff that's done in 312. If you took 312 and you liked the number theory in 312, that might be a thing that would be good. The dynamics course is dynamics. And you could also do independent study, right? Provided you have something that you want to do and you find somebody that is interested in doing it with you, that could also be. Or, you know, you could take, so like in the ed program, you can choose 341 or 342, but you can do both.
Is there any other burning questions?
Smoldering questions?
From an admission standpoint for graduate schools, a double major, is that going to, and for just courseload overall for an undergraduate, is a double major going to prove beneficial for someone who's looking to go to graduate school for math, or is it like, it had no effect, is it going to have a negative effect? What, is there anything there?
It probably depends on the graduate school.
But also on the student.
Yeah, and also on the students. I mean, you know, typically in our program, I'm mostly interested in the sort of advanced mathematics courses that the student takes, rather than, you know, doing economics or something. But sometimes, like, you know, physics can help if you're sort of, you know, if there's some sort of appropriate thing you're interested in which involves a bit of physics, for instance.
But it's not going to detract from it. You're not going to say, oh.
It's not going to be a negative, no.
So the only negative of it is that you would have less time to go more in-depth into mathematics, into pure math. If it's your goal to go to graduate school in pure math, then it might be more, you might be more benefit from doing more pure math rather than doing computer science on the side. But if the kind of math that you want to do is very, you know, just picking computer science as a random example, computational and related to computer science, then a double major might make a lot of sense. You know, so like if you were interested in machine learning, and especially the mathematics related to machine learning, probably Stony Brook isn't the perfect place to go, but nevertheless, there's some interplay there, and doing some pure math could help the understanding of what's going on in machine learning, and, you know, and the reason I picked that is because my daughter is a professor of machine learning, so, and she did that kind of thing.
Actually, on our e-board, we have a previous comp sci double major.
I just have some advice. Is like, if you don't think that you can handle it, like first get like a good understanding of like if this is right for you. Like I used to be a double major, and what ended up happening is I was flip-flopping between the two subjects, and I couldn't really focus on one. And then when I finally made my decision on which one I wanted to focus on, what ended up happening is I got too much workload from the other one, and I just lost interest, I lost my passion, and that ended up hurting my grades overall. So just make sure that you're not acting reactively and you're planning ahead, and you are understanding yourself in a sense.
I think this is a good place to end it, because we're a little bit over time now.
Yeah.
I will say there is advising available in the math department for faculty. There's a whole schedule for advising elements. So we post on the math department website that you can find online if you want help with individual advice and course selection or things like that. But yeah, that's about it. Thank you for that.